non-attractive product. How do I make this product not very attractive? First, doesn't sell.
Does it plus 1x3?
That's perfect. Okay, that's going to be very unattractive. Okay, 1 and x3. So which is x3, right? Okay. So this is the product. It only sells for $1. And to be even worse,
Resource constraints.
this guy is going to use a lot of resources. Okay, let's say use a lot of plastics. Let's say how about use you can any number you want. Okay, 8 x3. Doesn't sell very well. It uses a lot of resources. And even worse, this product probably also uses a lot of labor hours. Okay, so let's see how much. 5. You can do anything you want. So what do you guess is going to be the reduced cost for this? I mean, in order to make this product attractive, right? Not only sells for $1, right? And utilize so much resources, right? So guess what? If we solve this linear program at this moment, what do you think is the solution of x3? Do you want to produce x3? No. This should be 0, automatically 0, right? Okay. Okay. Now let's solve the problem. Okay, we got that solution. Okay, we don't even have to do sensitivity analysis. Because here we are. So what's the reduced cost? It's $28.20. So that means what's the current price of this product? $1. You make it $1. And right now, in order for this product to be attractive, you need to sell for $29.2 a piece to be competitive with the other two products you have. Okay, does everybody get an idea of reduced cost yet? Yeah. Okay, so it's, this basically tells you how bad it is. No, it's always positive. It's always, for the product which is not attractive, you always need an improvement. And the reduced cost tells you the amount of improvement needed. So it's always positive. Either 0. If it is attractive, it's 0. If it is not attractive, it's an improvement. Okay? So I believe. So why reduced cost is important in your organization? Because, I mean, here we only have 3 products, right? You can easily see that product 1 and product 2 are very attractive, right? Suppose you have 10 products, right? If you rank them, you can rank them according to the reduced cost. It tells you how unattractive certain product is. The reason you don't produce them, because then the optimal solution here is going to be all zeros, right? But if you don't have reduced cost, you just tell, the only information you have is going to be those products you choose not to produce. They're not attractive. But you don't know how unattractive they are, right? Then by looking at the ranking of the reduced cost, it tells you how unattractive it is. Okay?
Yeah. So, as we did, we made the x3 variable very unattractive. What if we do the opposite? If we make it very attractive, like half the labor hours, half the resources used, then what happens?
Okay, that's a good question. Anybody can clarify? Given this, okay, also.
The labor hours on the other products would increase.
The labor hours.
Or the reduced cost on the other, sorry. Reduced cost on the other products.
Okay, so
Just trying to download something.
okay, so what is going to happen is, and that's the correct answer. So what happened is, if you make x3 very efficient in comparison to the other 2 products, the solution is going to be, you're definitely going to produce x3, right?
Yes.
So x3 is going to be a positive number. But then what is going to happen in this particular case is going to be one of the other products will become unattractive.
So then the optimal solution, if we got 320, 360, it must change, right?
Your
Because
change.
we will get another optimal solution.
Yes,
with
we will
x3
get another.
involved.
Exactly. Yeah.
But could there be a 3-way optimal solution where you want a mix of the 3 products?
That's a multiple solution case.
Yeah.
You could have it.
Okay.
Yeah. But that's just boundary case.
Yeah.
Can I ask another question about, so if you introduce another product, as I was doing, you're going to use the research hold out and all that, the big rate. How do we evaluate that rate? That's a question. That's something we got to do. You're looking at time, you're looking at using a product, in the production line. We're reducing something by number of hours and resources. then our rate changes as well, because the product is more resources. Is that correct?
Anybody translate the question a little bit? I didn't fully capture the question. Anybody got the question?
So what I'm saying is, if you introduce another product,
Okay.
all right,
Help me. Okay.
all right, you're going to obviously use more resources. That means the rate that you're using your resources would change as well.
No, you don't have to use more resources, you have to stay within the constraints.
So
So-
you're saying, by just adding a product, inherently you're going to increase the amount of resources.
Right.
So the other one should be affected anyway.
Right, right.
You're going to competing with the current product.
Okay.
So if you introduce a new product, the amount of resources given, that means you're going to take away the resources
Right,
from the
that's
other two
right.
products.
That's assuming you're gonna use that product, even if you introduce it.
Exactly. Yeah. You may, if this product becomes attractive, you're going to competing with the other two existing products by taking away the resources. You're going to produce fewer of the other two products.
Right.
So here we are not talking. I mean, we are assuming the problem. You don't change the amount of resources you have.
Okay.
Yeah. Okay, looks like all of you guys get this idea. I mean, very clear, pretty well. Okay. So now we're gonna just do a review, then we're gonna do a real test to see how much you really understand. Okay.
Linda, okay.
Maybe I just want to catch that. With something else.
Let's do a review, then take a break, then we do the check. So the interpretation, we're gonna again the slack and surplus. Remember that's related to. So when you solve a linear program, you have two things in your mind. One is the product, the other one is resource. Okay, product and resource. Here we're talking about the resources. Okay. And slack and resource tells you how tight the constraint is. It's the difference between the right-hand side and left-hand side, right? Less equal to constraint is the resource constraint. It's the amount of resource available to you minus the amount of resource used. That's what the slack is, right? For greater equal to level constraints, it's the actual performance minus the requirement. It's how much you overperform, okay? And if this constraint has a slack, zero slack or surplus, that means the tight constraints, binding constraints is the bottleneck. That's something you're going to pay attention on, right? Okay. And if it's a slack or surplus greater than zero, that means either you have extra resource left or you overperform. No worry, right? Okay. And dual price, again, that's associated with the resources. Okay. Dual price for each constraint. It's the marginal value of additional resources or marginal cost of the requirement. Remember, what is the requirement? Protein requirement. If your customer says, I want more proteins, okay? So that means your production cost is going to increase, right? So the more requirement, more it's going to hurt you. So that the reduced dual price actually tells you the severity of the hurt, okay? How much it's hurting you in terms of production cost by requiring additional proteins or fat and so on. Okay? And in terms of science, that's a very confusing part. Depending on the software you use, sometimes they have positive signs, negative signs. They are not very consistent. But for me, I like the sign convention of Lindo. The Lindo there is very logical, and Excel is different. Okay. But once you understand the concept, the sign is not as important. I never look at the sign when I answer questions. Okay. It's all based on the concept. So for Lindo, for less equal to constraints, that means resource constraint is always positive. Dual price is always positive because it always helps you. And for greater equal to constraint, dual price always is negative because it hurts you. Okay. And usually don't discuss about the equality constraints. Okay. So if you have a constraint or the resources that has a dual price does not equal to zero, that means it's either valuable or it's going to hurt you, depending on whether it's a resource or requirement, right? That means at that time the constraint is tight. Because if the constraint is not tight, it's not going to help you and it's not going to hurt you either. Okay? This is almost like an old philosophy.
Can I ask a question on that?
Okay.
On the dual price for a requirement constraint,
Okay.
greater than or equal to, how would you interpret, like, in a sentence example sort of thing?
Okay.
How do you interpret the dual price?
That's a good question. Let's go to the dog food example. Dog food example, the first constraint says amount of protein you're going to have has to be greater than or equal to 3, right? 3 is the required protein level, 3 ounces. Well, in that case, let's say if you have a dual price, let's say it's 1. Let's say 2. Okay. So that means, okay, are you guys following me? We're going back to the dog food example. The first protein constraint means you're required to have 3 ounces of protein, right? Now, in that case, if the dual price equal to 2, actually negative 2, according to our convention, right? Negative 2. That means for every ounces of increasing in protein, your cost of producing a can of dog food is going to increase by $2. Okay, hurt means increasing the cost or reducing the profit. That means hurt. Okay, that's a good question. Okay, then we just did the interpretation, right? Coefficient, I hope 80% of you guys can answer this question. Okay? So basically, what's the range of the objective coefficient? I mean, the range of the prices. As we change the prices, right, what's the interpretation of the range? If the price changes within its range, what does not change?
The optimal solution.
Optimal solution. That's it. Okay, that's why I said 80%. Looks like not everybody gets the answers. Okay. Okay. So as you change the prices, if it's within the range, the solution does not change. The way you do the production does not change. Now for the right-hand side change, now I'm going to summarize again. Here we're talking about changing of the resources, right? As long as amount of plastics are within such a range, which is given, then what does not change? 3 things do not change. Bottleneck do not change. Dual price do not change. The third one I did not explain yet is the optimal solution structure does not change. Optimal solution oftentimes changes. Okay. What do I mean by optimal solution structure? That means the product that is attractive remains attractive. The product that is not attractive, and if you don't produce, remains 0. Okay, the number may change, but the structure is not going to change. So whoever you liked before, you're producing, remains. You're going to keep on producing, even though at a different number. But the structure do not change. Whatever that is attractive remains attractive. Okay, so that's another one. I mean, this one you have to prove, but just trust me, that's right. Okay, we have reduced cost. We just did an explanation. I did the explanation for the first sentence. Basically says, in order to make an unattractive product to attractive, to become attractive, right? Reduced cost tells you by how much you have to increase the price, right? And be able to sell.
It's actually related to the previous slide. So when you say the structure of optimal solution doesn't change, does the quantity, comparative quantity change?
Yeah, quantity usually changes. Just the sign does not change. Whether it's positive or 0 does not change.
Okay, so if X2 we are producing 360 and X1 320, X1 will always remain less than X2.
No. It's just a positive. Whether you keep on producing those products.
Oh, okay.
Okay, not the order.
Okay.
Okay, now there is second interpretation. Another way of looking at the reduced cost. It basically says, well, but sometimes your management tells you, no, even though it's not profitable to produce this unattractive product, but we do need to produce it because I have a customer pre-order, right? They've already ordered this product. Then the reduced cost basically tells you, if you are forced to produce this product, for every unit you produce, this is how much you're going to lose in terms of total profit. That's how much you're going to sacrifice. Okay, because to meet the customer demand, to meet the customer pre-order, for example. Okay, so as you can see here, this reduced cost is also a very important number. It tells you how much you have to sacrifice. If you violate from the optimal solution, you say, I have to produce. Well, this is a kind of an interesting slide, okay? So basically, finally, we have a relationship about the optimal, okay? So if variable means product, you say, I'm not going to produce, then you have a reduced cost. The reason you're not producing, not attractive. Reduce cost tells you how much you have to improve. If you're producing, that means positive, then you don't have reduced cost because it's already attractive. No improvement is needed. Okay? So that's almost like a dual relationship. And then for the constraints, you have a similar one too. For every resource, if zero means tight. If you're tight, it has a value or a cost. It's either going to help you or it's going to hurt you. That's why it's tight. And if it's not tight, means you have a slack, you have a gap. Then it doesn't have any value and it doesn't hurt you either. Everybody get it? Okay, simultaneous change, we're going to come back to on this one. And now it's good time to take a break because we're going to try to energize yourself. Now we're going to answer those 7 questions together based on your understanding so far. Okay. 10 minutes, so we're going to come back at around 8. 7.
So, just help me here quickly. Was it the site that you guys...
I don't. I just Googled, yes, Lindo, and downloaded the first thing, not the truffles. Yeah, I can go to the first one. Lindo, yes. It says optimization. Yeah, downloads, try.
Lingo.
Probably try this.
So when you look at products, you see
Yeah, so it should be Lindo API. Right? Yeah, so go to downloads and try Lindo.
what I was doing.
Download the first one.
You mean this one?
Yeah.
And then you have to figure out where the
I don't remember getting all that.
That's the point.